Question number 20. Find the value of I1 to I2 in figure 32E3 if part A R equal to 0.1 ohm, part B R equal to 1 ohm, and part C R equal to 10 ohm. Note from your answers that in order to get more current from a combination of two batteries, they should be joined in parallel if the external resistance is small, and in series if the external resistance is large as compared to the internal resistances. Here, this is first case, 6-volt battery, 6-volt battery with internal resistance 1 ohm and 1 ohm respectively. This is external resistance R, whose value can be varied. So in first case, it will be 0.1, then it will become 1, then it will become 10. This is second case when two batteries are connected in parallel. Internal resistances are same, means both batteries, these are same batteries, and this is external resistance R. Current flowing through it is I2. We have to find out the ratio of I1 and I2. For this purpose, let's calculate I1. Case 1, when R equal to 0.1 ohm. So I1 will be total voltage, that is 12, divided by total resistance 2 plus 0.1, that is 2.1, or 120 upon 21 ampere. And here, since both batteries are connected in parallel and they are equal in value, then EMF of only one cell will be taken. And internal resistance of these two cells will be considered. So I2 will be equal to 6 volt, and these two resistances are in parallel. So this will become 0.5 ohm, and this is 0.1 ohm. So total is 0.6 ohm. So this will give 10 ampere. Now we have to find out the ratio of the two currents. So I1 upon I2 will be equal to 120 upon 21 into 10, and that is equal to 0.57. Now consider second case. When R equal to 1 ohm. So if R equal to 1 ohm, in that case, total resistance will become 3 ohm. So I1 equal to 12 divided by 3, and that will give 4 ampere. And for I2, these two will give 0.5 ohm, and this is 1 ohm, so 1.5 total. So 6 divided by 1.5, so this will give 4 ampere. So ratio I1 to I2 will be equal to 1. Now, case third, when R equal to 10 ohm. So when R equal to 10 ohm, so total resistance in this case will become 12 ohm. So I1 will be equal to 12 divided by 12 will be 1 ampere. And in case of this, I2 will be, this is 10 and this is 0.5. So 10.5, 6 divided by 10.5. So this will give, this will become 60 divided by 105, which is, we can leave it here. Now we find the ratio of the two, I1 upon I2. So ratio will be 105 divided by 60. So 1.75. Now let's go to next question. Next question says, consider capital N equal to N1, N2 identical cells, each of EMF E and internal resistance R. Suppose N1 cells are joined in series to form a line, and N2 such cells are connected in parallel. The combination drives a current in an external resistance R. Find the current in the external resistance. Assuming that N1 and N2 can be continuously varied, find the relation between N1 and N2 R and small r, for which the current in R is maximum. So this cell has EMF E and internal resistance R. Similarly, second cell also has EMF E and internal resistance R. Similarly, here, as per question, N1 cells are joined in series. So there are N1 cells. And again, this is E with R internal resistance, and here again N1 cells. So in this way, there are N2 rows. So we can say total number of cells will be capital N, and that will be product of N1 into N2. Now we have to take into consideration the EMF of only one row. So EMF of one row will be N1 times epsilon. Now we have to find out total resistance. So of one row, internal resistance will be R N1 times. So we can say this will become N1R, then again N1R. Similarly, there are N2 such rows. So equivalent resistance 1 upon R equivalent will be 1 upon N1R plus 1 upon N1R plus dot 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 N2 times, which will become N2 divided by N1R, or from here R equivalent will be N1 upon N2 times small r. So equivalent circuit will be, we can write, suppose all cells are replaced by one cell of value N1E as we have calculated here, and the total resistance of all cells is replaced by N1 upon N2 small r, which is in series with a resistance capital R. Now we have to find out the current. So current I will be equal to EMF N1E divided by N1 upon N2 small r plus this resistance is in series with capital R. Capital R. Now we simplify. So we will get I equal to N1 N2 epsilon divided by N1R plus N2 capital R. Now, second condition is, assuming that N1 and N2 can be continuously varied, find the relation between N1, N2, R, and R, for which the current in R is maximum. So, in order to make current maximum, the denominator should be least. So, in order to make it least, let's do some calculations. So, for this purpose, we write N1R plus N2R equal to root N1R square plus root N2R square minus twice of root N1 N2 small r capital R plus twice of root N1 N2 small r capital R. These three terms can be written together as root N1R minus root N2R whole square plus twice of root N1 N2 small r capital. So we have got the relation for current as I equals N1 N2 epsilon divided by root N1R minus root N2R whole square plus twice of root N1 N2 small r capital. Now, for maximizing the current, if this term becomes 0, then current will be maximum. So we can put it equal to 0. So on putting it equal to 0, we will get the relation and that will give a required answer. So root n1r minus root n2r must be 0, or n1r under root equal to n2r, which further implies n1r equal to n2 capital R, which is a required condition. Thank you for watching.